My dears, now let me get you through on how to solve this calculus question, which is that trigonometry what function, right? Now, if this is the first thing that you are just seeing my video, make sure you follow me for for more science and mathematics tips. Okay. Now let's go through this equation now. Now we have to find the derivative of tan x. Now let's try solution first. When you are asked to find the derivative of this function, now what you have to do is what just say that let y represent this function. That means equals to this function, which is tan x, right? Now the next thing you have to do is that we are going to simplify this tan x. And tan x, like, what does it mean? It simply means that tan x or tan theta, whichever you want to put it, is equals to sine x over over cos x. I'm using x because we are giving x here. Okay, so I think you are giving theta. I'm going to use theta for through both sides. Okay, now let's go now. So now in this case now, we've gotten is tan x as sine x over over cos x, right? Now if you glass through this equation that is here now, or this formula here, now which of the terms in calculus that we are going to use? We say we have the product, the quotient, we have the chain rules, right? Good. Now in this case now, with the chain rules, we're going to just bracket with a square, like something like this, something like s plus 2 square, something like that. It's chain rules, okay? But the product rule, you're going to have like two brackets, right? But if it is now quotient rule, always deal with fraction, okay? Now this is a fraction now, right? So that means I'm going to use the word quotient rule. Now let's go now. The first one to do that we have to do is we're going to put each of these formula into a variable. Like, let's say we are going to use u for, because u comes before v, right? Now u equals to, we say let u equals to sine x, and what again? Then v equals to cos x. It means that we carry cos, put inside inside the u, then carry you carry sine, put inside u, then carry cos, put inside v, right? Good. So now having done that, now is that we are going to apply the formula now. Let's see. So now for quotient, the formula is the y over the x equals to, let's go, that's v du dx minus u dv over the x, and over v square. Now we've gotten our v, we've gotten our u, right? But now we need we need du dx, we also need dv dx. So which simply means that we are going to differentiate for this u and v. Are we here now? Good. So let's go for u first. We're going to have u as du over over dx, right? Now when you differentiate for sine, remember that it become cos. Okay, it's the constant terms that when you differentiate for sine, become cos. Okay, so I'm going to have the dx as cos x, right? Now when you differentiate for cos, give us minus sine. Okay, so I'm going to have dv dx now, dv over dx equals to now when you differentiate for this cos x, become minus sine x is constant. So I'm going to have minus sine x here. Are we good now? Though all this thing you are seeing, it has a proving. Okay, so but let's just take it as du dx as cos x, while dv dx as minus sine x. So you're shorting much of our time. Okay, so let's go now. Now apply applying this now, because we've gotten our du dx, gotten dv dx, and we have our u, we also have our v, right? So now let's put all of this now into this formula here, and we simplify it. Are we good? Nice. So let's go. So we have the y over the x equals to, now what is our v? Our v is cos x. So we have cos x here, then times, why join this du and dx? This u over dx and v is times, so that's why we are having times here. Now what's our du dx? Let's find it out. Du dx is cos x, so we have cos x here now. Then what do you have? Then minus, now what's our u? Can someone tell me our u? U is what? That is sine x, right? That's very good. So we have sine x here, then times, what's our dv dx? You have to ask minus sine x. So we have minus sine x. Then all over what? Over what's our v? Our v remain what? Cos x, right? So we have cos x. Now because it has square, right? Now it has square, so I'm going to put square in this place now. So now to differentiate, now I'm going to have cos times cos x times cos x will give us what? That will give us what? Cos square x. Just when you multiply x times x will give us x square. Okay. When you multiply this cos x times cos x will give us what? Cos square x. So we have cos square x. Then why when we add this minus now? Minus times minus will give us plus. Now sine times sine will give us what? Sine square x. So we also have sine square x over what do you have left? Now cos x squared means cos times cos, which will give us what? Cos square x. Are we good now? So I'm going to have cos square x in this place. Now the next one to do is what now? Is to what? To simplify what you have here. To have dy dx. Now according to what? To one of the what? The trigonometry identity. Now it said that when we have cos square x or cos square any variable plus sine square x or sine square any variable, will give us what? 1. You're telling me what? One of the identity what in trigonometry, which means that all of this now becomes what? Becomes 1. Is a rule. So I'm going to have 1 over what? Over cos square x. Now mathematically now, or now what I'm going to do here is that we're going to be applying what now? Trigonometry functions, okay? Or trigonometry identities. Now we apply the first one, we give us this one here. Now there's another term again in what? In trigonometry identity. I said that when we have 1 over sine, give us what? Cosec. Why 1 over cos give us what? Sec. Are we there now? So now what I'm going to apply in this place? 1 over cos will give us what? Sec, right? But because of the square, we're going to have it as what? Sec square x. Now this simply means that our dy dx give us what? Sec square what? X. Now I hope that this class you find it so interesting, right? Now don't forget to like the video, okay? Share the video, comment, and save it for your what? For future what? Reference, okay? So see you guys in my next video. Peace out.